This video is on the Apex Multifocal Corneal GP Lens. This is a platform that can be used on the presbyope to provide near, intermediate, and distance vision. It can also be used on the adolescent as a myopia controlling tool to create that signal to stop eye growth or slow it down. The Apex Multifocal is available through Cardinal Contact Lens in Cambridge, Ontario, as well as through Precision Technology in Vancouver, BC. The Apex Multifocal design uses some unique features, and that's a large diameter platform, a bi-aspheric surface, aspheric on the back, aspheric on the front. It uses a front surface ad to provide its multifocality, and it can customize the ad for each individual patient as well as the size that ad is distributed across. The large diameter of the Apex Multifocal is typically around 10.5 millimeters. So that's around a millimeter larger than conventional corneal GP lenses. And the idea is to lock that lens down on eye. By going larger, we decrease movement, we increase stability, and we improve comfort. It also uses a bi-aspheric surface to assist in improving comfort. And what that does is a high back surface asphericity creates a softer landing. It distributes its force over a broader surface area to create the most optimal comfort that's possible. So the combination of the larger diameter and high aspheric surface helps to improve initial comfort in patients. Now, in the application of the lens on a presbyope, the ad is designed specific for each patient. But additionally, the size of that ad zone is also designed specific for each patient. So we need to know the patient's ad as well as the pupil size, and each lens is custom manufactured for each individual patient. Now, in the application of myopia control, research has suggested that multifocal contact lenses reduce the axial growth. So by placing our kids into multifocal lenses, that plus that's created by pushing ad into the eye and distributing it across the retina seems to produce a stop signal for eye growth or a slow down signal for eye growth. Coupled with the Apex Multifocal, its large diameter and high aspheric, we can provide these young kids with very good initial comfort and also, of course, provide them the quality distance and near that they require. But most importantly, we're trying to push that plus into the eye to create that stop signal for eye growth. And this is where multifocal contact lenses can be beneficial. Now, rigid contact lenses in this application may be best for those patients with high corneal and refractive astigmatism, where soft torics may not be available in a multifocal, or they're not available in the type of powers that we need, or they're not providing the quality of vision that a rigid lens that can provide. To fit the Apex Multifocal, you have two methods. One, you can use the diagnostic set, trial fit the patient, determine the best base curve and overfraction, then order based on those parameters. The other option is to empirically fit from Ks and Rx or topography and Rx. In terms of lens selection, step number one is to choose the lens diameter. And this is simple. We would take the visible iris diameter measurement and subtract 1.3 millimeters to come up with our starting Apex Multifocal lens. In this example, we have an 11.8 visible iris, and we would subtract 1.3 millimeters from the total corneal diameter to come up with our initial lens. In this case, 11.8 minus 1.3 would equal 10.5 millimeters. Step number 2 is the base curve selection. And this is chosen by using a base curve 1.5 diopters steeper than the flat K reading. Now, why so steep? And that's simply because the Apex Multifocal uses a unique high aspheric back surface. And in order to create that soft landing in the mid-periphery with the high asphericity, the base curve in the center must be steeper to create the fluid layer between lens and cornea that we require. It is not at all typical to see apical steepening with the Apex Multifocal, and that may be because it has such a high asphericity of the back surface. So you have this very thin fluid layer in the center which tapers very quickly until it reaches its landing. To select the initial lens power, if we're using a diagnostic set, it's simply lens power plus the over-refraction vertex if necessary to give us the final lens power. In this example, if we had a trial lens power of -5 and an over-refraction of 75, our final lens required would of course be 575. Now if we're empirically ordering, we would take the vertex spectacle Rx, we'd add the 1.5 diopters compensation for the steep add minus. And in this example, if we had a 4.5 diopter spherical component, vertex to 4.25, add our 1.5 diopters lacrimal lens compensation, gives us a 575 final lens power. Now to determine the near, this is also relatively simple. We just determine the patient's add power as well as the pupil diameter in normal illumination, and then we order the two together. So if your patient's add is 2 diopters and we have a measured 4 millimeter pupil, then we would order +2 add at a 4 millimeter diameter. What we're attempting to do is distribute the entire power range this patient requires for near, intermediate, and distance vision. Once you have the data that you need, simply call, fax, or email customer service or your Precision or Cardinal consultant, and they will process the order and get it off to you as soon as possible. Now to evaluate the fit, there's a few things that we want to do to ensure that we create the optimal outcome for the patient. To evaluate the fit, the first step is to determine the apical clearance. Does the lens clear the corneal apex? Is there fluid between lens and cornea? If this happens, then we can land down in the mid-periphery and create the stability, the centration, and the comfort that we require. If the lens has inadequate clearance, if it hits the central cornea, it's more likely to decenter, in which case we want to steepen the base curve approximately a half diopter or 0.1 millimeters. If the lens has excessive apical clearance, it's hard to make out the pupil. We may even be getting a bubble and it's associated with inferior displacement. Then we want to flatten the fit a half diopter or approximately 0.1 millimeters. So determine that you have the appropriate apical clearance first. The next step is to evaluate centration. To provide the multifocality and quality vision required, an Apex Multifocal must center over the pupil. If the lens is radically decentering, that's going to hinder quality vision and create aberrations that could be problematic for the patient. Check that the lens appears well centered to the pupil. A high-riding lens is typically a flat lens, so in these cases we would either steepen the base curve or reduce the eccentricity. This is something the consultant can assist you with. When you have lateral decentration, this is often also due to a flat fit, in which case we would want to steepen the base curve. When you have a low riding lens, that is typically a tight fit, and we would want to flatten the base curve or increase the eccentricity to essentially loosen the lens and bring it up. Your consultant can assist you with this process of evaluating the fluorescein together and alongside the centration of the lens. It can usually tell you which direction that we need to go. So employ your consultants to help you through the entire process. Step number 3 is to evaluate the edge lift. And what we're looking for is a 0.5 millimeter width of band of fluorescein all the way around, or a 0.5 millimeter width of edge lift. Now, you can get away with less or more edge lift as long as there aren't any slit lamp signs, issues with comfort, or problems with the lens popping out too easy, or having difficulty removing the lens. So ideally, we're looking for a 0.5 millimeter width, and we can adjust that as required. If you have that ideal edge lift, then we know the eccentricity of the lens is matching very closely the eccentricity of the eye, and changes aren't required. However, if you have a lens that has the appropriate apical clearance, it has the appropriate sagittal depth. However, it has inadequate edge lift. If it's too tight, we need to increase the eccentricity of the lens to better match the eccentricity of the eye. So you would order standard +1 as the standard adjustment to improve edge lift. Conversely, if we have excessive edge lift, wider than that 0.5 millimeters that we're targeting, if the lens is moving around radically, if the patient's uncomfortable, then we know we need to decrease the edge lift. So here we have a lens that has the appropriate apical clearance, but we simply have too high an eccentricity for this eye. So the central relationship, the sagittal depth of the lens is good, but the eccentricity of the lens is excessive. In this case, we would order standard -1 as the typical adjustment to reduce that edge lift. We can go in smaller increments or larger increments as required, but a 1-step plus or minus is the typical adjustment to make a significant change. Now, step number 4 is to evaluate the distance vision, and a well-centered Apex Multifocal should provide quality distance visual acuity. If the lens is decentering, the patient is more likely looking out of more plus in the lens and an asymmetric distribution of that power. So getting the lens on center becomes critically important to our success. Now, if the distance vision is poor, determine the overrefraction that may provide quality vision. If that overrefraction does hinder the near vision, then we may need to make our change in the dominant eye only. One of the things that we can do to the lens is to decrease the add, and what this does is it enlarges the distance zone of the lens and creates less power distribution within the pupil. And this can be helpful to improve the distance vision. Normally this is done only in the dominant eye, decreasing the add. Another thing we can do is increase the pupil size. By enlarging the area that we distribute the force over, this can enlarge that distance zone and push less plus or less asphericity into the pupil. So there are many options that we have to attempt to improve the quality of distance vision for patients. But centration is the key to start with. Now, step number 5 is to evaluate the near and intermediate vision. And again, a well-centered Apex Multifocal will give us the best chance of simultaneous vision. So when you're evaluating either distance or near, make sure that you confirm where that lens is centered. Now, assuming the lens is well centered, both in primary gaze and when the patient looks down to read, but we still struggle with intermediate or near vision, then attempt to push the plus. Push it binocularly, determine if you can achieve quality near acuity, then ensure that that doesn't affect the distance. Now, if we need to make changes in one eye only, of course, this is typically going to be done in the non-dominant eye to improve the intermediate or near vision. And that can be done two ways, similarly to how we modify the distance. We can alter the add by increasing the add. It pushes the plus closer into the center, crowding the pupil with more magnification. Again, this is typically done in the non-dominant eye only. We can also decrease the pupil zone size, and that will create more magnification within a smaller area. So if, for instance, we've calculated the lens with too large a pupil size, and we actually have a smaller pupil, we wouldn't be distributing the add within the appropriate size to provide the multifocality. Again, with the near and intermediate vision, centration is key to provide simultaneous vision. Then if we need to push more plus or increase the add or decrease the pupil size, we have numerous options. If you'd like more information about the Apex Multifocal, contact your Cardinal or Precision consultant, sales rep, or customer service, and they'd be happy to assist to provide the fitting guide or additional information on how you can acquire the lens.